On a quiet beach at night, a wave crashes, and instead of vanishing into darkness, it glows. Blue sparks swirl in the foam, lighting the sand as though the stars themselves had fallen into the sea. And in the stillness of a forest, faint green mushrooms shimmer softly on a rotting log. And in the deepest parts of the ocean, creatures carry lanterns of their own, making glowing like galaxies in the black abyss. This is bioluminescence, life creating light in the dark. Welcome to the Tilted Planet podcast, sharing journeys, stories, and a little wonder from around the world. I'm Jack, your host, and today we're venturing into the glowing mystery of bioluminescence. From fireflies flickering in summer fields to vast bays of ocean that shimmer like liquid stars, bioluminescence is both a survival tool and one of nature's most breathtaking displays. In this episode, we'll explore its science, its stories, and the sense of wonder that it inspires. For as long as people have gazed into the night, they've noticed glimmers where none should exist. To sailors crossing vast oceans, it appeared first as ghostly light trailing beneath their ships. The wakes of oars and rudders shimmered with an eerie blue glow, as if the sea itself were alive. Some believed it was magic. Others thought it was a bad omen, a warning from the deep. In Europe and Asia, glowing fungi that sprouted on fallen logs became known as the foxfire or fairy fire. Farmers and villagers walking through the woods at night sometimes stumble upon these patches of faint green light, mistaking them for spirits or even wandering souls. And of course, fireflies have danced through summer evenings for as long as we can remember. I can certainly remember times seeing them myself. Their rhythmic flashes spark myths of fairies, ancestors, or tiny lanterns carried by the unseen hands. In Japan, they became symbols of love and fleeting life. In North America, children still chase them across fields, cupping their flickers in small hands like captured stars. Bioluminescence has always stood at the edge of mystery. To early observers, it wasn't just a curiosity of nature, it was a glimpse into something otherworldly. Today we understand the mechanism, though it remains no less magical. At the heart of bioluminescence is a chemical reaction between two key ingredients, a molecule called luciferin and an enzyme called luciferase. And no connection to the devil. The word Lucifer actually means light bringer. When luciferin reacts with oxygen in the presence of luciferase, the enzyme, it releases energy in the form of visible light. What makes this light remarkable is its efficiency. Nearly 100% of the energy is actually converted into light, not heat. That's why it's called cold light. Different species have evolved slightly different versions of the reaction. Some glow blue, others green, yellow, or even red. Color depends on the type of luciferin used, and sometimes the environment. Salt concentration, acidity, or the presence of other molecules can also change the color. But understanding the how only deepens the question, why? What purpose does glowing serve? Well, bioluminescence isn't a random quirk. It's a survival strategy honed across millions of years. For instance, to hunt in the depths of the ocean, the anglerfish dangles a glowing lure above its head, drawing curious prey close enough to be swallowed whole. Some squid release glowing clouds to confuse predators, much like an octopus releases ink. Then there's hiding. Paradoxically, light can also serve as camouflage. Some fish like lanternfish and hatchetfish use bioluminescence on their undersides to blend in with faint light from above, making themselves invisible from below. This is called counter-illumination. Then it's also used for warning. Tiny plankton known as dinoflagellates glow when disturbed. When a predator or a passing boat stirs in the water, they flash blue as a defensive mechanism. To small predators, the sudden glow may startle. To larger ones, it acts like a spotlight, attracting even bigger hunters who might eat the attacker instead. Then there's communication, of course. Fireflies flash in distinct patterns to signal potential mates. Each species has its own rhythm, a kind of light language written across summer nights. Bioluminescence, then, isn't just beauty, it's survival written in light. For most of us, bioluminescence would feel rare. But when you know where to look, it becomes one of nature's most magical spectacles. In Puerto Rico, on Mosquito Bay, which is on the island of Vieques, it is considered the brightest bioluminescence bay in the world. Each stroke of a paddle or splash of hand ignites millions of microscopic plankton, turning the entire bay into a glowing canvas of electric blue. Other glowing bays can be found in Jamaica, the Maldives, and part of Southeast Asia. And you may have even seen some videos or pictures of these. Then there's also glowing shores along the shores of California and Australia. Seasonal blooms of bioluminescent plankton sometimes make entire waves light up as they crash, transforming coastlines into scenes from another planet. Glowing fungi are scattered across tropical and temperate forests. In Brazil, the flor de coco mushroom glows with an eerie green, while in North America, there are species that light up fallen logs. In New Zealand, glowworms dangle silk threads from cave ceilings, glowing softly to attract insects. Tourists floating beneath them often compare the sight to drifting through a galaxy of stars, but underground. If the surface world gives us glimpses of glowing, the deep sea is where the phenomena really truly reigns. Imagine drifting thousands of meters beneath the waves, into a world without sunlight. Here, bioluminescence is everywhere. Jellyfish trail along, glowing tendrils, some pulsating rhythmically like living neon ribbons. Squid pulse with sudden bursts of light, and some even have rows of photophores along their arms that flash in intricate sequences, potentially communicating with other members of their species. Some fish even have headlights, you could call it, beneath their eyes, using them to search for prey in the endless night. One of the most spectacular displays comes from siphonophores, relatives of jellyfish, that can grow longer than a blue whale. These organisms form chains or nets of glowing individuals, appearing as a drifting, shimmering lattice through the blackness. Then there's dragonfish, which are masters of stealth, using red light invisible to most prey, giving them a tactical advantage in hunting. Hatchetfish and other midwater species use counter-illumination, as mentioned earlier, producing light from their undersides to match the faint sunlight from above, effectively erasing their silhouettes to creatures below. Other deep-sea creatures have evolved unique strategies. Flashlight fish blink in coordinated patterns. Yes, you heard that right, flashlight fish. Possibly to maintain schooling behavior in the darkness. Comb jellies pulse with iridescent waves, casting rainbow glows across the water. Tiny shrimp, amphipods, and even plankton emit flashes that ripple through the abyss like distant fireworks. Explorers and submersibles describe it as falling into a night sky, but instead of stars above you, constellations swim all around. Every flicker is purposeful, to attract, distract, warn, or hide. In this endless blackness, light becomes life's most versatile tool, shaping predator-prey dynamics and communication in ways humans are only beginning to understand. Now, beyond their beauty, bioluminescent organisms have changed science in profound ways. In the 1960s, researchers studying a type of jellyfish discovered green fluorescent protein, or GFP. This protein, when inserted into other cells, causes them to glow under certain light. Today, this GFP and its variants are essential tools in biology and even medicine, allowing scientists to track cells in real time, illuminate genetic activity, and observe the spread of diseases. Without this discovery, countless breakthroughs in molecular biology would have been impossible. Even before GFP, bioluminescence sparked wonder in naturalists. In the 18th and 19th century, explorers cataloged glowing fungi, fireflies, and marine organisms, and of course they were fascinated by their survival strategies. During World War II, sailors were startled to see glowing plankton trailing submarines, reminding us that bioluminescence can interact with human activity in unexpected ways. Modern scientists continue to unlock secrets. Some are engineering glowing plants to monitor stress or detect disease. Others are studying plankton blooms to better understand ocean health and even climate change. Astrobiologists examine bioluminescence to theorize how life might survive in extreme extraterrestrial environments. Each discovery links natural beauty to practical knowledge, demonstrating that bioluminescence is not just aesthetic, it's a window into biology, chemistry, ecology, and the adaptability of life itself. Across cultures, light in the darkness has always carried meaning. Bioluminescence naturally slipped into myth and story. Japanese tales speak of fireflies as the souls of warriors or lost lovers. In Appalachian folklore, foxfire was sometimes seen as a sign of ghosts lingering in the woods. Sailors once feared glowing seas as omens of storms or misfortune. But the modern story is different. Today, people travel across the globe to witness these glowing beaches, glowing bays, or glowing caves. Scientists no longer see warnings, but opportunities for discovery. Tourists no longer see omens, but magic. Bioluminescence continues to shift our perspective from fear to fascination, from superstition to science. Bioluminescence reminds us that the world is never as dark as it seems. Light is not only born of the sun or fire, sometimes it comes from life itself, glowing quietly in the shadows. From fireflies and glowing fungi to plankton and deep-sea lanterns, nature has found countless ways to shine. It is survival, it is wonder, and it is a reminder that beauty often thrives where we least expect it. Join me next time on the Tilted Planet podcast as we explore the quiet rhythm that shapes our days. Until then, keep exploring, keep wondering, and tilt your perspective. And if you've enjoyed today's episode, please leave a like or a comment. And if you'd like to support the show, you can even buy me a coffee with the link in the description.